Good morning, everyone. Now let's continue our topic about implicit differentiation and let's solve like more complicated questions in case we have to use implicit differentiation. When do I have to use implicit differentiation? Whenever we can't isolate y. So whenever we can't isolate y, that means we will not be able to apply differentiation rules that the normal ones that we've learned together. So what are we going to do? Let's have an example, something like this one. For example, he said, for this question, it's an example. So he said in this question, he said find differentiation of y with respect to x for what? For y squared equals x squared plus sine x y. Okay, so what shall I do here? First of all, we are going to ask ourselves, can I isolate y? No, we can't. Why? Because here I have here y and there y, so we'll not be able. So that means I don't have any other option except what? Except using differentiation or implicit differentiation. This y contains x, no clear x, so that means I'm going to apply chain rule. Okay, this x has a clear x, x squared, so I'm going to apply differentiation rules. Okay, and sine here we are going to apply differentiation, sorry, chain rule. Why? Which one? The one that has this one, f of g of x, right? So what's the differentiation of this one? It's f prime of g of x, of the same thing, times differentiation of g of x, right? It's the same idea. So here we are going to apply chain rule first. Then x, I'm going to apply differentiation rules. Then for y, we are going to apply chain rule. But how we are going to apply it? Using product rule. Using what? Product rule. Okay? So see here, what do I have? We are going to write just x and y here just in case we want to like to solve it later or we to copy the answers later. So here I have x and y. So what is x here? This is u. Excellent. U is x. U prime is 1. V is y. V prime is differentiation of y with respect to x. Okay, I'm going to just keep it here. Then apply implicit differentiation. Y squared, we are going to apply chain rule. So it says take the power as a coefficient, reduce the power by 1, then differentiation of this function, which is contains x, equals x squared, which is here, 2x, plus sine xy. What's differentiation of sine? It's cosine. Cosine of what? Cosine of the same function as we applied here, as we wrote down, chain rule. So cosine of the same part, x and y, times differentiation of this one, which is the product rule. The product rule says 1 times y plus x, differentiation of y with respect to x. My goal is what? My goal is to isolate differentiation of y with respect to x. So I'm gonna now distribute. Okay, now distribute. Here it's gonna be what? Here it's gonna be what? 2y differentiation of y with respect to x equals 2x plus, I'm gonna enter here, so I'm gonna write this y before cosine to avoid any kind of confusing, cosine xy plus, also I'm gonna write this x before, so we can just write here x cosine xy times differentiation of y with respect to x. How many terms here do we have contains differentiation of y with respect to x2? So I'm going to just take this one to the other side. That's it. So it's going to be what? Differentiation. And also we take differentiation of y as a common factor. So it's going to be 2y minus x cosine xy times differentiation of y with respect to x equals what? Equals 2x plus y cosine xy. I want differentiation of y with respect to x alone, so we are going to divide both sides by the coefficient here. So we are going to divide it. So I'm going to divide here and there. So finally, differentiation of y with respect to x equals 2x plus y cosine x and y, or x times y, over 2y minus x cosine xy. Okay, I hope it's clear for you. Let's have like one more easy question. I think it's enjoyable, right? Okay, let's continue here. Like for example here, if I have this question, this is like an example, another example, right? I like a little bit, like more interesting. He said find second derivative of y with respect to x squared. If I have here 2x cubed minus 3y squared equals 8. So first of all, here we are gonna say that what does that mean? That means this is second derivative, right? This is second derivative. So what should I do? We are going to differentiate for the first time. So this is the second derivative. So differentiate the first one. Differentiate with me. Again, x contains x clearly, so I'm gonna apply differentiation rules, excellent. So here it's going to be 2 times 3, which is 6x squared, reduce the power, minus 3 times 2, which is here chain rule. So we are going to have a chain rule. So it's going to be like this, 3 times 2y times differentiation of y with respect to x. What's the differentiation of 8? It's 0. Okay, now I'm going to remove this 6x to the other side. So 3 times 6, which is 3 times 2y, which is here, 6y differentiation of y with respect to x equals here negative 6x squared. Now we will divide both sides by negative 6y, negative 6y. So now differentiation of y with respect to x equals x6 and 6 has gone and negative has gone, so it's going to be x squared over y. Now we will take this one again and differentiate it another time. That means we will get the second derivative of this function. So it's going to be something like this. Differentiation or second differentiation of y with respect to x squared. Here, what do I have here up? I have clear x, so this is differentiation rules, right? What do I have down? Function contains x, so here I'm going to apply chain rule. How we are going to apply this? We are going to apply this using quotient rule. Excellent. Can you remind me here what's quotient rule? It's u over v prime equals u prime v minus u v prime over v squared. What is u here? U here is x squared. So u prime is 2x. V is y. So v prime is differentiation of y with respect to x. Okay, apply the rule here. So it's going to be what? It's going to be 2x y, right? Minus x squared differentiation of y with respect to x over v squared, which is y squared. What is differentiation of y with respect to x? If you have just, yes, excellent, it's this one, right? So I'm going to substitute now, substitute. So it's going to be second derivative of y with respect to x squared equals here 2xy minus x squared times, let me change the color, times x squared over y squared. Here, what do I have to do? This actually over 1. So I want to make same denominator to simplify this fraction. So it's going to be here 2xy squared minus x fourth or x raised to 4 over y squared. Applying the rule that says keep, change, flip. So I'm going to keep this side, change the division to be multiplication, okay? And here flip this one, so it's going to be y squared over 1. I'm trying to explain each single detail, that means you will not get confused for any reason. So this one is going to be second derivative of y with respect to x squared equals 2xy squared minus x raised to 4 over y times 1 over y squared. So it's going to be y cubed. I just simplified directly, so I wrote the answer. If you want to rewrite it again, so you want to rewrite it in the simplest form, you are going to write it here, this ones and this one, using addition and subtraction. So it's going to be 2xy squared over y cubed, so it's going to be y minus x raised to 4 over y cubed, which is the final answer. Hopefully it's clear for you. Okay, let's take like one more question. Okay, let's have like one more or two more questions here. Here in both, actually, the question basically asks you to find what is differentiation of y with respect to x, or he asks you to differentiate. Again, here x contain there is clear x, so we can apply differentiation rules directly, and y here contains x, so this is chain rule. Cotan, this is chain rule because this is f of g of x. Okay, so we are going to apply first of all chain rule. Then after this x is differentiation rules. This y is what? This y contains x, so it's gonna be what? It's gonna be chain rule again. How we are going to apply this? Product rule here and there. Okay, so we are going to just write here uv. So I have here x and y. So u here is x, u prime is 1, v is y, v prime is differentiation of y with respect to x. Okay, I'm going to just keep it here. So we are going to apply. For x and y, the relationship between them is multiplication. So we are going to apply product rule 1 times y. So it's y plus x differentiation of y with respect to x equals. Now I finish from the first one. What's the differentiation of cotan, which is negative cosecant squared of xy, right? Times differentiation of the half, which is here y plus x differentiation of y with respect to x. Enter here this one because I want to isolate cosecant. I want to isolate differentiation of y with respect to x. So it's going to be here y plus x differentiation of y with respect to x equal, I'm going to just write negative y cosecant squared xy minus x cosecant square xy times differentiation of y with respect to x. So I will take all the terms that contains differentiation of y with respect to x on one side. So it's going to be here x differentiation of y with respect to x plus, because it was negative there, plus x cosecant squared xy differentiation of y with respect to x equals here negative y cosecant square xy minus y. We will take differentiation of y as a common factor, so it's going to be here x plus x cosecant square xy times differentiation of y with respect to x equals here negative y cosecant square xy minus y. So divide is going to be here differentiation of y with respect to x equals negative y cosecant square xy minus y over x plus x cosecant squared xy, which is my final answer. Okay, let's take or come back to the last example. Here I have x plus 10. So plus here, that means I don't have any problem. So I'm gonna differentiate each one like simply each one separately. Differentiation of x here is 1. 10, we are going to apply the rule that says f of g of x. So we are going to apply chain rule. The rule here says what? Says f prime of g of x times g prime of x. Okay, so it's going to be here 1 plus what's the differentiation of tan? It's secant square xy, which is the same thing, times differentiation of g prime. Already we've done this there, here, and the other side, so I'm going to write it directly. There's going to be y plus x differentiation of y with respect to x, then this equals 0. We are going just to enter. So 1 plus y secant square xy plus x secant square xy differentiation of y with respect to x. Remove everything to the other side. So it's going to be here x secant square xy differentiation of y with respect to x equals negative 1 negative y secant squared x and y, or x times y. I want differentiation of y with respect to x alone in one side, so it's going to be negative 1 minus y secant squared xy over x secant square xy. Okay? Okay, I hope it's clear for you. Thank you very much and have a nice day.